Hello everyone, my name is WANGNAN. Today I will present my project is from forecasting accuracy to business value, a decision-oriented framework for retail demand forecasting. This project examines how demand forecasting creates business value in retail inventory decision, while forecast accuracy is commonly used to evaluate models. It does not always translate into better business performance. Our results show that forecast error direction and risk context significantly affect profit, stackout, and downside risk. To address this gap, we propose a business value-driven post-process framework that improves profit and reduces extreme losses without retraining forecasting models. Retail demand is highly volatile and uncertain, making demand forecasting critical for inventory and replenishment decisions. In practice, forecasting performance is often evaluated using statistical accuracy measures such as RMSE and MAE. However, this metric trade over forecasting and under forecasting symmetrically and ignore the economic consequences of errors. At the same time, inventory systems operate under asymmetric cost structure where stackout costs are much higher than holding costs. As a result, there is a clear gap between forecasting accuracy and realized business performance, particularly in terms of profit and risk exposure. This study helped for research project first to compare forecasting accuracy with business performance. Second, to examine the impact of forecasting error directionally. Second, to evaluate forecasting performance under different risk scenarios. Finally, to propose a process for work without retraining forecasting model. This study uses the Fresh Retail Need 15K dataset. It is a real-world retail transaction data. This analysis is done at the SKU store and daily level. In total, 6 forecasting models are evaluated. This includes graded Bayesian models such as XGBoost, like GBM, and Cat Bayesian. We also evaluate random forest and LSTM and TCN. First, forecasting model generated demand forecast. Next, their forecasts are embedded into a unified inventory simulated system. All models use the same replenishment policy and cost structure. Then, business performance is evaluated using profit, start rate, and downside risk. Finally, all models are compared based on their business outcome. 2 operating scenarios are considered in this study. The first is a standard scenario. The second is a high-risk scenario. With the high Stackout penalties. Business performance is evaluated using the three metrics. They are average profit, stackout rate, and downside risk. This figure compares forecasting accuracy with business outcomes, include profit and downside risk. The key takeaway is that accuracy, besides ranking and not align with business value or risk outcomes, models with very similar RMSE can lead to fundamentally different profit, losses, and risk exposures. This means that if managers select forecasting models beside on RMSE alone, they may choose models that performs well statistically but increase business risk. This figure compares the impact of underforecasting and overforecasting. The key takeaway is that underforecasting is substantially more harmful than overforecasting. Underforecasting is lead to significantly large profit losses and higher downside risk. This is because its metric cost structure applying the economic impact of stackout from a managerial perspective. This implies that inventory decision should be more conservative against underforecasting, especially in high-risk environments. This slide shows the effect of BVFPP. BVFPP improves average profit while reducing stackout rate and downside risk. More importantly, this improvement are achieved without retraining or modifying the forecasting model. Only a decision layer adjusting is required. This makes the framework scalable and practical for real retail systems with thousands of SKUs. In conclusion, forecast accuracy does not automatically translate into business value. Forecasting direction and risk context fundamentally shape inventory outcomes. By applying decision layer post-processing can significantly improve profit and reduce extreme losses without retraining forecasting models. These findings proved clear and actionable implications for retail inventory decision-making. This study uses a simulation beside the inventory setting. This replenishment policy is fixed. Future research can extend this work to dynamic pricing and other industries.